Hi, I'm Dr. Altman. I'm here in Cincinnati, Ohio. I'm standing outside the Reutter mansion. This building has been in the Reutter family since it was built back in the 1930s. It's a beautiful home. I will be staying here tonight as a guest. As it turns out, my hosts aren't here yet. They showed me where the key was. I've made myself at home. I've been looking around and I want to show something to you. You will notice that this building goes up for several floors. A beautiful watchtower up at the top. Here we have a tower with an ideal view of the entire countryside. I wonder how difficult it would be to calculate how fast a tomato would be traveling if it fell from that height. What would I need to do? Well, first, I would have to measure the distance to that point. I could easily do that with my tape measure. And then I would need to have a tomato. I happen to have one. And then what I would have to do is drop the tomato, and as it plummets to the ground, I could determine its velocity. Let's go ahead and try that.
All right, so here's what I've got. I've got potential energy of a tomato up at the top. Potential energy is equal to m times g times h, the height of the building. Now the height of the building I measure directly. Height of the building h is equal to 11.25 meters. Gravity is a known, 9.8 meters per second squared. The mass of the tomato is an unknown. I looked over the house, couldn't find a triple beam balance. Now I really want to know the velocity of this when it hits the bottom. So if I knew the potential energy, I know it gets changed to kinetic energy, and kinetic energy is equal to 1/2 mv squared. So that's going to get me my velocity. But I don't know mass. But I don't know mass on either side of the equation. So here's what I can do. This is kind of an algebra trick, and this is why they teach you algebra in the first place. You can set the two equations equal to themselves. The potential energy is going to turn into kinetic energy. It's just like at Niagara Falls. Potential energy at the top changes into kinetic energy at the bottom. So my potential energy is equal to mgh. My kinetic energy is equal to 1/2 mv squared. I don't know m, so I really don't want it there. So I divide both sides of the equation by m, and m divided by m is 1. It essentially cancels out. So I'm left with g I know, h I know, 1/2 I know, and v I'm looking for. Multiply both sides by 2, take the square root of both sides, and that solves for velocity. Algebra is so cool. Glad I stayed awake.
It has just occurred to me that, first of all, it would be rude to drop a tomato onto the front driveway, front porch of some people who are letting me stay in their house. Second, and probably more important, I have no way of directly verifying the actual terminal velocity of that tomato. So I think I'll just eat the tomato this way. Thanks, Joyce. Wait a minute. I know the distance. If I release it at a starting velocity of 0 and time it as it falls, I'll know the total time, total distance. I can find average velocity. If I know initial velocity is 0, then the final velocity would have to be twice the average velocity. If only I had another tomato. Should I or shouldn't I? These are great tomatoes.